Hello and welcome to another fun-filled video on Math with Mr. Sims. This is our Cycle 20 review, otherwise known as Help, COVID-19 Stole My Memory. By the way, that's not something that it does, but if you are looking at this and you are like, I have never seen that before in my life, then either one of two things happened. You might have missed the Thursday right before spring break, which is when we did it. The other thing that might have happened is you might have just forgot because let's face it, it's spring break. So anyway, what we're going to do today is we are going to review. We'll pretend like you basically have never seen this before, and I'm just going to go through it. And in the future, we'll do more videos where we're just doing new stuff, you know. Obviously, this is uncharted waters. We're all trying to figure out how do we handle this the best. We want to make sure that you guys are ready for Algebra 2 that's coming up eventually your way, college that's coming up eventually your way. Just because the world's gone crazy a little bit doesn't mean that everything stops. So we're going to try our best to teach you the best we can from distance learning. So let's do it then without further ado. So I hope you're having a great day. By the way, we have missed you. I should have started with that. We've missed you a ton. We've missed you tremendously. And you know, it'll be good to see you again sometime, give you guys a fist bump. Yeah, but anyway, hope you're having a great time at home, that you're getting all the things done that you need to get done. And without further ado, let's go ahead and begin. All right, so Cycle 20, Algebra, we're talking about correlation versus causation. That's one of the topics that we're talking about. So looking at correlation versus causation here. So, I'm going to just zoom out just a little bit. I move this over here. Here we go. So, an ice cream truck driver is expected to see is excited to see the sunshine, and he believes his ice cream sales depend on the sun. Is this a fair assumption? Now, I want you to think about that for a little bit and basically give an answer in your head, and then we'll see if you're right or wrong. All right, so hopefully you've thought about that a little bit, and a lot of people, their knee-jerk reactions is to say, yes, it in fact does depend on the sun. But actually the answer is no, not really. So there's two types of events that we're talking about here. One is called, I'm going to try and
do this. And you know what, let me try like this. Sorry, 1 second here. There we go, let's try this. Yeah, I think I like that. Let's do that. So the first one is going to be called correlation. That did not work, so let's try it. Let me try that one more time. If that doesn't work, I'll just move on to something else. Whoa, okay, that's really big. You know what, that's going to be more problems than it's worth, so let's not bother with that.
All right, so the first type of correlation is, the first one is called correlation, all right? And correlation, what correlation is basically a relationship in which two events are observed together. And so the gentleman, if he's thinking about his business, he would in fact be right that this is what we call correlation. Now, if you're worried about my handwriting, if you can't read it or anything like that, I do want to stress to you that it can that all of this information is already on Google Classroom, so that you can actually look at the completed notes and fill it out that way if you want. This is just me explaining it to you, okay? So this is correlation. Correlation describes a relationship in which two events are often observed together. But there's another type of relationship, and this relationship is called causation. Causation, all right? And causation is the type of relationship in which a second event is understood to be the consequence of a previous event. All right, so I did figure out a little bit. So correlation and causation, those are those two right there. And once again, causation is when the event is understood to be the consequence of a previous event. What I mean by that is this. It's basically saying that this one must occur, all right? Or it must follow. In other words, if something happens, then this must happen. That's how I kind of like to think about it. It kind of helps out a little bit. So here's an example of just a comic strip that kind of illustrates the principle a little bit. Some of the most famous geniuses in the world slept only 4 hours per night. This is what the guy's thinking, right? He's like, I'm doing 4 hours a night too, because you know that what they say, correlation is the same thing as causation, right? And the guy's like, no one says that. He's like, oh, right, and I should take the word of an oversleeper, right? But this one, once again, the pointy-haired boss, what he's messing up here is he's messing up the difference between correlation and causation. Although it is true that many geniuses did sleep 4 hours a night, that's correlation. This is a trend that we see. It does not mean that you suddenly sleeping 4 hours a night is going to cause you to become a genius. So there's a difference between something occurring together and something necessarily being a result of something else. Okay, so let's go ahead and look at some more examples here, and we'll look at a couple more examples, and you tell me what you think. So, temperature in ice cream cells, is it a direct cause? So, once again, we just said it is no, not a direct cause. Okay. How about hours studied and graded on a test? Is it a direct cause? Hopefully, you thought about that. The answer actually is no. I almost tricked you by writing yes. It is actually no. The although yes, we do notice a direct correlation between people who study, right, and the grades they would get on tests, right? There's definitely a correlation. The amount you study, if you hours you study, depending on the grade, yeah, you would definitely notice there's an upward trend there. The more you study, the better grade you would get. So absolutely, there's a correlation, but there is not causation, because it is possible you could study really long and you would expect this grade, but in fact you might just bomb the test, right? There's lots of reasons that could happen, right? So just once again, it's not necessary, it won't necessarily follow. Okay, the number of miles driven and the amount of gas used, is it a direct cause? Well, think about it this way: you have a little car, right? Here's your little car, and your little car, you go for a drive. When you drive your car, assuming it is a gas car, right? We are making that assumption. So if it is a gas car and you drive that gas car, right? You gotta love that picture. Okay, as you drive, you will use gas, right? It's a necessity. Therefore, the answer to this, the number of miles driven and the amount of gas used, is a direct cause. The answer would be yes, right? Absolutely, it'd be yes, because frankly, there's no way to drive that car without gas. So you driving it will increase the gas you use. Amount of children, level of maturity, is a direct cause. If you have more children, will you have more maturity? We would like to think the answer is yes, but in fact the answer is no, because you could have a lot of children and not be mature at all. What we do notice is people who have children, they tend to start thinking about themselves a little bit less, and as a result, they do get more mature. But once again, it is not a guarantee. Okay, so number of pages printed and the amount of ink used, is it a direct cause? Well, let me think here. Number of pages printed, the amount of ink used. Well, I definitely need ink to print. Ergo, yes. By printing, I will definitely use ink. So yes, it is a direct cause. This would be an example of, once again, causation, right? All these other ones, by the way, have been correlation, in case you've missed it. Correlation, okay? All right, let's continue. So, number of years go to college attendant, average salary, is it a direct cause? The answer is no, right? No, there are some people who make a lot of money having not gone to college at all right? It's not the norm. It tends to be the case. This correlation. It tends to be the case that if you go to college, that more opportunities open for you, and your salary does increase. But it is not necessarily something that follows. Okay, so let's go ahead and move on to something else. All right. So anyway, that was correlation versus causation. Hopefully that made sense to you. Let's go ahead and do line of best fit. So your line of best fit, what we're looking at with line of best fit is we're basically trying to literally do that. We're trying to make a line that fits the data best. And I'm going to go ahead and do this. You always want to use a straight edge when you do this, because what you don't want to do is create a situation where you have a line that's like this, where it's not even a line of best fit at all, right? And frankly, even if you did draw it almost right, that's not a line, right? We want a line that we can be able to map out later, right? So to do a line of best fit, what we're doing is, once again, this is line of, sorry about the chicken scratch, best fit. Okay, line of best fit. And this right here, if I were to do a line of best fit for this one, what I'm aiming for with these is you want to basically have about the same number of points on each side, all right? So I'm going to go ahead and make, you know what, let me try this. I like this. that to me looks like I'm going to have about the same number of dots on either side, right? Here's I have 4 and 4. That's a pretty good line of best fit if I do say so myself. I like it. All right, but once again, if you're just eyeballing it with your ruler, that's kind of what you're shooting for. It doesn't necessarily matter that they exactly have the same number of points on best on each side, but that's just a nice kind of rule of thumb that kind of helps you figure it out. This might be a line of best fit. No, I don't like that one. I don't think that's the one. Maybe it's this one. That's a pretty good line of best fit, I think, for that data right there. I choose that. Maybe that's good, right? Something like that. All right. How about this one here? The line of best fit might be something like, yeah, I could go with that, right? And the whole point is you're trying to minimize the number of distance for all the points to the line. There's ways you can do that with math, but in fact, where the calculator does it for you later on, we'll figure out how to do that, but we're not going to do that right now. But basically, just so you know, those are how you kind of draw lines of best fit, right? Okay, let's go ahead and do this one. Let's try using the line of best fit to make predictions, right? So first thing you got to do with this is you got to actually make a line of best fit. So I'm going to go ahead and draw a line that looks like maybe a line of best. That looks pretty good to me right there, actually. So if the graph to the right shows the amount of dollars and millions that was spent on CDs from 1999 to 2005, based on the graph, what is a good estimate for the amount of money spent on CDs in 2006? Well, here's 2006 right here. This is going to be '06, right? So anything up here. So it looks like the line crosses basically right here at this point, which if I look over to my left here is 650. Because it's 650, sorry, that was supposed to be more straight. Because it was 650, it is $650 million, right? So $650 million, right? And that seems to follow the data. If you look at the data seems to be saying that, hey, it's going to get less and less and less each year on using those CDs. And we've actually seen that, by the way. If you go and look at sales of CDs, they've definitely gone down as people use more things like iTunes and things like that, right? All right, let's go ahead and move on to the next one. The table to the right shows the average and maximum longevity of various animals in captivity. Right, so graph the points, then draw a line of best fit to predict the maximum longevity of an animal with an average longevity of 33 years. So the first thing they want us to do is take all these points here, and they want us to graph all these points on the thing. Then we can see the points, then we can draw our line of best fit and go from there, okay? So let's go ahead and go from the average. Remember, the average is on this side, so this is going to be my x values. This is going to be my y values, right? So my average is 12 and 47, which is going to be right about there, I think, right? 12 and 47, right? And the next.
So let's go ahead and drew some of these points there. There's that point there. There's that point there. There's that point there, 2550, right? The next point is, all right, 1540. I did 1540 there. I'm going to do, what is that, 820? 820 is going to be right here, right? Oh, it's right, not there. 8's about there, right? 820, okay. The next one is going to be 3570, right? 35 and 70 is going to be right about, nope, not there, there, right? And 4077, 4077 is right there, right? And 4161, 4161 is right there, right? And there's 2054, 2054, which is going to be right there, okay. So that's basically my line there, right? I'm going to go ahead and do, let's go try. Okay. So, all right, now what I'm going to do is I'm going to go ahead and make my line of best fit.
And I'm actually going to make my line of best fit go through 2 points just to match the notes. But once again, you would kind of be able to kind of look at it and figure out where it would go. You want to draw your line of best fit first usually, and then find 2 pretty points. But just to make this sure this matches the notes for you, I'm just going to go ahead and make sure it goes through those 2 points there, okay? So I'm going to go ahead and so let's go ahead and go there. And let's go ahead and go there. All right, so that's basically my line of best fit, right? Now, as you can see, it went through those 2 points. It went through 30, 60. I'm going to go ahead and draw 30 and 60 here, right? And it also went through 10 and 30. So that's 10 and 30, right? So I have 30, 60, and I have 10 and 30, right? And now what I want to do is I want to actually figure out what is my equation for that line. Now we've been doing this for a while now. Once again, we have 2 points and we want to make an equation of a line from 2 points. So what I'm going to do is I'm going to I go 30. I'm sorry. Let me actually do, this is going to be my x1, my y1, my x2, and my y2, right? So this is going to be 30 minus 60, right? Over 10 minus 30, right? I really could have done that the other way. It probably would have been better. But anyway, you get 30 minus 60, you would get the negative 30, right? And on this side here, you get a negative 20. When you simplify that, that becomes 3 halves, right? Positive 3 halves. So my slope is a positive 3 halves. So I now have the positive 3 halves slope. That's my m. And remember, I want to get my y is equal to mx plus b. This is the form I'm looking for. Y is equal to mx plus b, okay? So my b is, my m is 3 halves, so I'm going to go ahead and plug that in, right? 3 halves. My x, I can leave the x just like that, and y as well, so I can put in x and y values. And my b, my y-intercept, as I can see right here, looks like about 15, so I'm just going to put 15. So let's say this is my equation of the line, okay? So if that's my equation of the line, y is equal to 3 half x plus 15. Now what I have to do, since they want to know what's the predicted longevity of an animal, of it if it has an average longevity of 33 years in the wild, right? So in captivity, what I can do is I can put in that 33. So I go y is equal to 3 halves times 33 x. Oh, sorry, that was my x. Plus 15. And when I calculate that out, I'm going to get a number. That number, when I calculate it out, is going to be about 65 years, okay? And I chose to round it in that case because they don't need a particularly accurate answer for that, okay? So all right, so there's 65 years. All right, I'm going to go ahead and move on from there then. Hopefully this is making sense to you. Let's go ahead and do another one. Let's go ahead and do this here. The table below shows the number of hours spent studying. So this is once again that example of what we called correlation, right? It's not causation because it doesn't necessarily follow, but we can kind of predict what would happen if we did study, right? There's definitely that relationship we see. So the table below gives the points. Let me go ahead and draw them out real quick. X is 2. I'm going to go ahead and label all this grid so that I have some good spots to work with, okay? So, what happened to my cursor? Okay, that was weird, but I think we're good now. All right, so once again, I have 0, I have 1, 2, 3, 4, 5, 6, and 7. And this is the number of hours basically the guy studied, right? He could either study the 1, 2, 3, 4, 5, 6, 7, or none at all. And 55. I'm going to make 55 my lowest value on this side, okay? And the reason why is because all our data seems to be above 55 here. So 65, right? 70, 75, 80, and 85, and 90, and 95, and 100. All right, so now that I have all my points labeled, I can go ahead and plot all these points and make my line of best fit. So I have, at 2 hours, he got about a 77. 2 hours and 77 looks like it's going to put me right about here, okay? So 2 hours and 77 right there. The next one is 592. 5 and 92 puts me right about, I don't know, about there, right? You know what? Let me make that just a little bit. There we go. Ooh, that's a lot. Oh, that's too big. Okay. Let me try that again. Let's try. There we go. There we go. All right, there's that. There's that. Let me go to the next one, 1 and 70. 1 and 70 is going to be right about there, right? And the next one, 063. 063. That sounds about right. And 490. 4 and 90. Dude, way to go with the studying. 2 and 75. 2 and 75, right? And finally, 3 and 84. 3 and 84. All right, so I have them all there. Basically, what I'm going to do is I'm just going to draw my line that goes straight through them. It's going to basically, well, here, I'm actually going to make it match the notes completely. So it looks like the notes used this point, and it used a point up here, okay? Once again, so that was just when we drew our line of best fit. That's where it seemed to go, and I figured we can be consistent with the notes, okay? So there we go. So that's my line. So I'm going to say it went through this point and this point right here. Let's say that went through that point a little bit better than I showed right there. So what I'm going to do now is I have my 2 points, right? My 2 points are... Okay. So my 2 points then are 170, right? 1 comma 70, okay? And the other point is going to be 6 comma 100, right? That is so ugly. 6, that is so ugly. Okay, so 6 comma 100, right? So these are my 2 points, 1 comma 70, 6 comma 100. So this is going to be my x1 and my y1, and this is going to be my x2 and my y2. And I'm just going to go ahead and start by finding the slope, which is going to be 100 minus 70, right? All over, that was ugly, all over 6 minus 1. All right, so you do that, you get 30 over 5, which is equal to 6. So my slope is 6, which is cool. All right, so now I'm going to put it into y is equal to mx plus b form, right? So I have y is equal to my slope, which is 6 times x, right? Plus my y-intercept, and as I can see, my y-intercept looks like it's about, what, 63, 62, 64, maybe 64. Let's go 64. So plus 64. All right, so there's my thing right there. So, so y is equal to 6x plus 64. Now, what score would you expect from a student of 6 hours? Once again, I just take my equation I just made. Well, this is my beautiful equation here. Right? I take that equation and I go y is equal to 6 times 6, right? Whoop. Times 6 plus 64, right? And if I do that, I get 36 plus 64, which is going to equal 100. So hey, if you want to get a 100, and actually that doesn't work. This is not saying that for every test you have to just study 6 hours and you'll get the 100. That's not what it's saying, because this is once again for that particular subject, that particular teacher, that particular type of exam that teacher tends to make, right? Our exams might be harder. It might take you longer than that to study for it, or it could be easier. It might take you much shorter than that to study for it. So once again, that just gives you an idea of how correlation works, though. So once again, we made our line of best fit, and then we calculate what that line of best fit is, and then we plugged in the values to predict for it. So kind of cool. All right, so last thing here is 2 sets of data can have. There's 2 things they can have. They can either have what we would call a, I thought that would go. Did it go? All right, so they can either have a, let's go ahead and do that, positive, whoops, why is that not working? They can either have a positive correlation or they can have a negative correlation, right? And there's another type of correlation they can have, okay? Just so you know, they could also have no correlation. Ignore this right here. This should not be there, but this is a negative correlation. We would say no correlation, okay? So they can, in fact, have no correlation. Sorry about that. All right, and you can also have, what's that? You can also have strong or weak correlation, right? Strong, right? And I'm actually going to minimize this just a little bit to make it fit in that cute little box, okay? So strong, or you could have a weak correlation, okay? So a positive correlation will have a positive, what we call slope, right? Slope. Whoops. Okay. The other one will have a negative slope, right? Slope. Okay. And sorry about that. That did not turn out how. There we go. Ooh, I like that. Let's do that. Okay. Slope. There we go. And the next one, the stronger the correlation, the more linear it's going to look. Okay. Linear. So once again, if it looks like a line, if the data really looks like it's a line, then what we're saying is that it's basically a very, very, very strong correlation. Okay. So let me go ahead and go back to my pen now. So this one here, if I'm looking at this graph, let's just go ahead and start by just telling me if it is strong or weak correlations. Okay, so in this case here, you can see that it is a pretty strong correlation, right? So I would say this is a strong correlation, right? Strong, right? This one here, you can see there's an upward trend to it, but it's not very much like a line. So this is what we call a weak correlation, okay? Weak. This one here is pretty strong, actually. It's almost a line, right? It's getting there. So that's a pretty strong. It's not as strong as this one. This one was very strong. This one's pretty strong, but not as strong. This one's definitely weak. This one here, when you're looking at what correlation that is, the way I like to say it is if it looks like stars in the skies, if you're just looking at it and it looks like stars in the sky, then that was what we call an example of no correlation, okay? So if you're just looking up and it's not looking like the Milky Way or anything, it's just looking like just a random smattering of stars in the sky, then that's no correlation, right? There's no trend. It doesn't look like it's going up or down. It's just no correlation, okay? This here would be an example of weak correlation as well, okay? All right, let's go back now and tell me if it's positive or if it's negative, weak, strong. So this one here is a strong, if you look at the slope is going down, so this is a strong negative correlation, right? Strong negative correlation, sorry, that should be negative. All right, this is a weak positive correlation, right? Weak positive, right? This is a strong positive, right? And the next one would be no correlation. Is it going to be weaker? Is it going to be positive or negative? That's a trick question. There is no positive or negative with no correlation. It's just no correlation. And this one finally is the weak negative. All right. There's a definitely negative trend to this, right? Once again, it is a weak correlation, so that's a weak negative. All right, well, that basically covers all the bases. Don't forget, this is this time, great time. Go ahead and fill in that summary so you don't forget it later. All right, so basically, we did correlation versus causation. We talked about what makes it correlation or what makes it causation, right? We did the line of best fit here. Here's our beautiful, wonderful line of best fit. And then when we used those line of best fits, right, we came up with the equations for them. And we basically figured out how do we predict data based on that. That happens all the time, by the way. In case you're wondering, you're always asking, when will we ever use this? Well, by the way, people do use this all the time. So this right here is, once again, another example that we did. And then finally we did types of correlation. Don't forget, if it's a positive slope, right, like this, it's going to be a positive correlation, right? The more linear, the closer to a line it is, determines whether it's a strong or a weak correlation. Well, I hope that's been a wonderful time for you. Thank you once again for joining me in this endeavor. Keep safe, keep social distancing. Listen, make sure we can beat this thing, but we got to beat it together. So, once again, just make sure you're distancing yourself socially from the other people. I know there's people you'd love to see. I know you would love to come over to say, Mr. Sims, hey, let's say hi. But no, seriously, I know there's people you would love to see, but this is not the time, all right? So, hey, just be safe out there. Wash your hands frequently. Don't pass on germs to other people. And I wish you the best. When this is all over, I look forward to giving you guys a fist bump and talking to you and seeing how your break was. All right, have a wonderful, wonderful, wonderful experience, and I'll see you soon.
I need somebody to heal, somebody to know, somebody to have, somebody to hold. It's easy to say, but it's never the same. I guess I kinda like the way you numbed all the pain. Now the day bleeds into nightfall, and you're not here to get me through it all. I let my guard down, and then you pulled the rug. I was getting kinda used to being someone you loved.